Our next speaker is Johannes Oster from TU Wien and the Center for Artificial Intelligence and Machine Learning. Johannes teaches and lectures in generative AI at TU Wien and is actively involved in research and AI engineering, bringing both academic insight and practical experience into the field of AI. Please join me in welcoming Johannes Oster to the stage.
Thank you for the lovely introduction and for the opportunity to talk about technical approaches to protect one's art against the unauthorized use for AI training, style transfer, style theft maybe, and things that we even aren't aware of right now. Inspiration has always been a thing. But generative AI allows pretty much everyone in this room to replicate pretty much any artistic digital asset at a precision and speed and scale that we have never seen before, that inherently deflates the value of artifacts that have been previously hard to create. It's basically a widespread de-evaluation of mastery in general. There's never been a meaningful opt-in or opt-out form of helping to improve or create this technology. And arguably, it's not the primary objective function of big corporates to ensure the well-being of individual artists, and very likely it will never be. So the question of how can I protect my art if others don't care is a very good one. And the short answer is, the clicker won't work. The short answer is you don't. There has never been more money and human intelligence involved in progressing this technology. The economic value of improving the model's capabilities is immense, and the importance of new, raw, organic data is very high. Whenever this is the case, the incentive structure works against data protection. And then protective research always tries to fix the problems that exploratory research creates in the first place, so it always lags behind. However, most of you still lock your door. Arguably, for a very sophisticated thief, they could still break your door. So technology alone will not be the solution, but it is a necessary friction. It is a symbol of ownership. It is a manifestation. Do not go in here. So we'll try to avoid telling you fairy tales about perfect plug-and-play solution that will protect all your art until the end of our days, but I will try to outline what's currently possible and give you the things that increase the friction, so at least the cost of stealing your data is high enough that big corporates need to start thinking about whether they should rather license it. At a very high level, one can categorize the different approaches into data provenance techniques and adversarial machine learning. The right-hand side is about evidence, making sure that when your data has been stolen and an AI has been trained on it, you know it and you can prove it. The other side, adversarial machine learning, is decreasing the value of your data, ensuring that even if someone steals your data, it is basically useless for training. We will look at 4 different sub-approaches: forensics, watermarking, data poisoning, and style cloaking. What is forensics at a high level? Does it even work? And what is the caveat? Very skim overview, because as you can see at the bottom, it basically doesn't work. The high-level idea is to detect whether data has been used for AI training or not. How you can do it is you look at the inner behavior of a model. So you look does the activation pattern within the neural network look? Is it similar for data that it potentially has been trained on, close to data that it has definitely not been trained on? And based on this difference, you can say, has my data been stolen, yes or no? The big caveat, and why I tell you that it's probably not bulletproof, on the one hand, it often requires a white box scenario, meaning that you need to access the model weights. And most of us are not able to access the model weights of, for instance, Midjourney. There are open source models, but most of the damage does happen outside of them. The second thing is, there is not yet any well-established tests that say this works across all the different models. There's quite a significant false positive rate, so saying the data has been misused even though it hasn't, and therefore until we are at a point where we could use it as a legal proof, there has to happen a lot of things. I still want to add it for completeness, but my basic saying, it is interesting from an academic perspective, but far away from a legal proof perspective. The idea of watermarking is simple. You take your images and then you engrain a consistent pattern in the pixel values, and then it can be used for training. The idea is to use the hypothesis that most neural networks are lazy learners. They rather try to learn simple patterns than more complex patterns. So if all your data has a consistent pattern ingrained in it and is labeled by that's the style of Johannes, the model learns to reproduce this consistent pattern when I prompt it for the style of Johannes. Then afterwards, if someone asks, please create me new art in this style, the idea is that these watermarks are consistent and can be found in the data, which would not be possible if my data has never been used before. Again, the summary slide, it has some promising results that are consistent and transferable, generalizable across multiple models. However, again, we have not yet seen widespread tests across all the models. And the big thing is there is no plug-and-play solution for you. So while it would be possible if you do a collaboration with a big university and spend a bunch of $1,000, you could replicate the results from the research. I don't think you're here to do that. So while this is very promising, it's not yet there on a product perspective. If you want to dive into the research, that's the best paper I can recommend to start with. Let's get a bit less depressing to the second part of adversarial machine learning with style cloaking and data poisoning. As said, the data provenance is about evidence. Adversarial machine learning is about sabotage, reducing the value of your data. At a very high level, currently, I can prompt whatever style by Michael Whelan, a famous artist from America, and Stable Diffusion will give me perfect images in his style. The idea behind data poisoning is that I take the original images. Then I do small data modifications that are unseeable to the human eye, but visible to the machine. Why is this possible? Because still we haven't really figured out how human perception works at a level so that we can replicate it. So computer vision works significantly different to human vision. So small modifications at a pixel value completely potentially destroy the vision of the computer, but are undetectable to us. The idea is to do such modifications so that when you train on the modified data and then ask again, bring me some style by Michael Whelan, you get a bunch of garbage. So it's about not really ensuring that no one trains on my data, but once you train on my data, you basically cannot replicate my style. At a very high level, how does it work? You take an original image. Then you take what we call an anchor image. For data poisoning, we use a different theme. For style cloaking, we use a similar context, but a different style. The idea is the same. Take an anchor image that is different to what we use. Then we have this subtraction. Keep in mind, it's not really a subtraction, it's an iterative optimization to ensure moving the original picture closer to the anchor image while keeping the human perception to a minimum, so the difference that is human perceptible. There are models that are actively trained on measuring perceptible similarity. So we use this as a guard to avoid destroying the image, but try to move the pixels as close as possible to the anchor image. So we get, this is not what happens really because you wouldn't be able to see anything. It's just basically random pixels for your eye, but something like this. And then if we ask, okay, now please add this modification to my original image. As you can see, you don't see anything. There's no visible change. However, when I now train the model on this modified data, and I take the trained model, this is my new stop sign. So I would say it's an image, but not that useful. If you would apply style cloaking, you would maybe see a stop image, but when I am Van Gogh, I would see some other artist that has nothing to do with Van Gogh. The summary slide again. Does it work? There is a limited functionality for image to image. I'm always starting with the down caveat of here. What is image to image? You can have text to image where you prompt, please create me something in the style of. And you can add a reference image, and then it takes this image as a base and tries to recreate this image with some modifications that you ask it to do. The reason why this works less is because in the act of using image to image, we fundamentally, quote unquote, destroy the original image down to individual pixel values and then recreate it, which destroys any modification that we have. If you really increase your data modification to a very high level that it becomes humanly perceptible, it still works pretty well. But it's a way off that you have to decide, do you want to publish your data as you want it to look, or with visible modification but strengthen your ability to shield it away from misuse. However, the good thing is there's currently no technology known that fully undermines this for text to image. There are some papers that claim we have completely removed or undone this, but there are constantly updates to the product I will show in a second to also conquer this. Keep in mind, there will never be a technology that solves any of these problems because obviously it's possible to gather all the data from the internet, then wait 100 years, pay 1,000 PhD students to do nothing else than removing your data modifications until they have figured it out. So I'm not here to tell you, do this and your data will never be stolen, but it's like a locker on your bike. Obviously, if I just leave my bike without a locker, it will be stolen more likely than if I have some locker. And together with other legal solutions, societal change, even change in ethical perception of what it means to steal art, it will be feasible and it will be a good enough symbol of saving your data to make a difference. So as the goal of this panel was introduced to avoid you just sending out your data, my key takeaway here is try this product called Glaze. It's from the Chicago University and by far the best thing we have right now. You can literally download the software. it takes roughly 20 minutes afterwards because there is some machine learning involved to get down the weights. But you can download it, you can drag in your own images. These images are not uploaded. Everything happens on your own device. You can choose the amount of data poisoning or style cloaking you want. You can see the results. So you can also try to make it as big as you are not able to visibly see the modifications. And then you can upload it into the internet. As said, it will not be a future-proof solution. But currently it's the best we have, and it's pretty good, because if I, as the normal user, have the opportunity to either take all your data and then download it, fine-tune my own model, replicate it, and I have a great thing, or I take your data and then it takes me 40 days to remove the data poisoning, I will obviously rather take his unprotected data. So that's definitely my key takeaway. Download Clays and try it. So again, technology alone isn't and won't be the solution, but please stop just publishing your artistic artifacts without any protection, and style cloaking or data poisoning is currently the best we have, so use it. Thank you.
Thank you so much to Johannes for that great presentation. And I know after that, there has to be some audience questions. We do have, again, 5 minutes of Q&A. So don't be shy. We're all in this together. I'm sure someone is probably thinking it and is really happy if you ask it. So anybody? No? All right, maybe a bit later. So I will ask a question then. In the beginning, you did make a comparison between people just publishing their data to someone breaking in a locked door. And you said, although we lock our doors, it is still possible for people to break in. I thought that was interesting because it's a very physical comparison to something AI related, which we think of as maybe more abstract or digital. Can you please explain a bit more why you chose that, or what exactly you mean by that?
Yeah, so the idea was that I looked for references where we already have technical solutions as a protection that work pretty good, but that are not 100% safe. I watched a lot of YouTube videos when I bought a pretty expensive bike for sports purposes and thought, okay, I need a certain level of protection to get my proper insurance, because that's the actual protection that I have. And then I looked at a bunch of YouTube videos on how to crack these different locks. And basically there was a YouTube video for every lock that it took like 40 seconds to break it. So in terms of pure technology, it isn't a solution, but somewhat we have built up a system that it still is a good protection. So I choose this as an example. And the second thing is, I think it undermines that there are other things that keep us from stealing certain things. And it's not only because we are not capable. Right. And I think currently we do not have those things in place. Because I think for all of us, and it was mentioned, our inner how do you call it, hurdle of just typing something in by the style of is basically zero. So for some reason, we do not go out on the streets and steal a car, but why do we suddenly just steal basically the mastery of 20 years of other people? So something has to change. I'm not totally sure what, but there is more to it. So.
Okay, interesting. Thank you. All right. Yes, perfect. A question that is not for me. Great. Just wait one moment, please. We'll bring you the microphone. No problem. Thank you so much.
Thank you. Concerning that it takes some amount of time and specialized knowledge to handle one's images or whatever in a way that you can't steal it so much. Don't you think the better way would be to offer that as specialized knowledge by some companies, so that artists or whoever wants to publish blurred images of their works to go to a company and ask for that service to get it done? Because I think you need a lot of computer specialized knowledge to do that. Don't you think it could be possible that some companies, startups, whatever, offer this kind of service?
So in general, the last thing I showed you is pretty simple for a non-technical user. It's a visual, graphical user interface product where you drag it in. Obviously, which I would argue is a step further, if you really want to protect your data, it's probably a combination of multiple things. And definitely, yes, there is a big opportunity. Why hasn't it been created yet? On the one hand, I think the ease of training your own models has been significantly higher 1 year ago. So the problem really increased in the past half or 1 year. And also the technology then to counteract that is really new. So like the papers are 2025, mid of the year. But I definitely think there is and will be a bunch of startups that tackle this problem.
All right, perfect. Oh, we have one more question. Okay, do we have time for one more? I'm so sorry we don't, but we do have a panel discussion at the end, and there will be Q&A after every session. So thank you so much again, Johannes.
Thank you.